project provided by the tech startup known as Yonata aims to collect the newly discovered orange soil located on the moon's surface. A team of like-minded engineers were tasked at creating a technological-ready Level 3 prototype which is capable of collecting and returning samples to and from a lander in a simulated environment. Yonata aims at creating the foundation for interplanetary exploration focused on regolith resource extraction. Yonata provided initial restrictions on the prototype which the team had to incorporate into their build. The prototype had to be able to fit inside a 15cm cubed pod for the initial landing phase, whilst having a total weight limit of 800 grams. The extraction time for the simulated scenario was set to a total time of 5 minutes to collect a total of 3 samples scattered around the environment. Yonata also provided the team with an initial $185 budget for the final version of the prototype. Now, let's meet the team.
I'm William, and I worked on the mobility system of the robot. We used a 4-wheel system with 2 42mm diameter wheels at the back and 2 40mm diameter wheels at the front. These were powered by the L2988 motor drive, the H-bridge. Where the robot relies on a differential steering system, this is where one wheel is set to a slower speed and the other is set to a faster speed to turn left or right. We use 2 low current 6V micro metal 30x1 motors to drive the wheels. Each motor has a no load speed of 450 RPM with a stall torque of 0.29 kg per centimeter. Now these were plenty of power to drive up the lander and navigate around the field with ease.
The sample collection subsystem, as the name suggests, is responsible for ensuring the robot is able to collect the lunar samples scattered across the challenge environment. This expectation is comprised of many specific requirements for the system, including flipping rocks and lifting, carrying and dropping samples into the lander. The system achieves this by rotating an arm, using an SG90 servo motor connected through a pair of gears. The arm is specifically made for the task and is designed to lift and cup the golf ball shaped samples perfectly, as well as flip the rocks by positioning its prongs underneath it and lifting. The design of the sample collection system is made to be self-contained, reliable and strong, as well as compact, light and cheap, to ensure it does its part to keep with the overall budget and design constraints of the challenge.
Hi, my name is Eden and I worked on the vision system for our robot. Our vision uses the Raspberry Camera V2 to visualize the field in front of the robot. This camera feed returns a constantly updating picture in the red, green, blue color scheme, also known as the RGB scale, which we instantly convert to the HSV scale known as hue, saturation and value. The robot then splits this feed into different color thresholds to identify what the robot is seeing. After the vision has identified the object, the range and the bearing are then calculated, instantly providing information for the navigation system to use.
Hey, my name is Sean and I designed the navigation system for the rover. This system is responsible for taking what is seen from the vision system and relaying that for an action to be taken by either the sample collection or mobility system. Using logic systems, I was able to make the robot navigate towards samples, rocks, and the lander depending on the situation, whilst also avoiding obstacles. The navigation system is vital to the project, as without there would be no brain for the robot and it would mindlessly drive into the wall.